Hello, today we are working on PO4, the greatest common factor of a set of numbers. So that greatest common factor is a PO, that means it is a power objective, and that means we need to make sure that we pass all of our POs so we can move on to algebra next year. Those COs are the ones that we talked about. We only need 80% of those passed. A power objective, you need to pass all of them. So that means that if you get 3 or 4 right on your test, that you get that 75%, that is passing. So that is what we're looking for. So we really need to make sure we understand how to find the greatest common factor. We are going to start with our factor. A factor is a number that goes evenly into a number that goes evenly into the given number. An example of this would be if our number is 12, its factors would be 1 and 12, 2 and 6, 3 and 4. Those are all factors of 12. If I divide 12 by 2, I get 6. It's an even number, or not an even number, it evenly goes into it. So there are no leftovers, no remainders, no decimals. So there are 2 different ways that you can find that greatest common factor. The first one is finding the GCF using those. So it actually goes backwards, GCF. So we start with the F. That is the factors. You need to list all factor pairs. I call them factor buddies. So you list all of those factor pairs or their buddies of each given number. So that's what we did up here with the number 12. We found the factor pairs 1 and 2, 2 and 6, 3 and 4. And if you're going to find common factors, you're working with at least 2 numbers. So another thing would be if we'd have maybe another given number of 20. And we'd have to find those factor pairs, their factor buddies. So 1 and 20, 2 and 10, 5 and 4. Those would be factor pairs for 20. So for each number that you're given, if we were given 12 and 20, we would find the factor pairs for them. The second step is the C. You're going to circle the common factors. So if I look back up at our examples, we have 1 and 1, 2 and 2, 4 and 4. Those are the only ones that we have in common. So then the G is identify the greatest common factor. So we need to look at all of those factors that we just circled and find the biggest one. So we have a 4 and a 4 are the biggest factors that they shared. So our greatest common factor is 4. So again, to use finding the greatest common factor with the listing method, you need to find the factors, find the common factors, and then find the greatest common factor. So you work your way down. You have to be very careful that you find all of the pairs of factors that go into the number. All right, let's look at our second method. That is the prime factorization. So to do the prime factorization, we use a factor tree to find the prime factors of each number. So use factor tree to find the prime factors of each number. And then our second step is find the product of the common prime factors. So using those numbers that we just had up top, if we have 12 and 20, we would make our factor tree. What can go into 12? So when I look at factors of numbers, if it's an even number, I like to keep it simple, and I always start with the 2. So the factor buddy for 2 would be 6. 2 is a prime number, so I don't have to go any smaller. 6 can be broken down. Again, I always look for that 2. 2 times 3 is 6. So what my product list would look like there would be 2 times, so we've got our 2 times 2 times the 3. Those are our 3 prime factors that go into 12. So now let's do the 20. Just going to move that over so we have room. Again, I like to start with the 2. You can start with any factor pair that you want to start with. You could start with 4 and 5. Like I said, I like to start with my 2s. So I have my 2 and my 10. 2 is a prime number, so it stays. 10 can be broken down to 2 and 5. Those 2 and 5 are both prime numbers. So what my multiplication would look like would be 2 times 2 times 5. So then I'm going to look at my 2 sets of primes, 2 times 2 times 3, 2 times 2 times 5, and see what primes they all share in common. I see a 2 times 2 and a 2 times 2. There's no 3 and no 5 that are in common. So I'm just going to look at 2 times 2, and 2 times 2 equals 4. And we get that same greatest common factor. So they both get us the same answer. We just get there in a different way. So let's look at some more examples. So if we have 40 and 72, we're going to find our factor pairs. So let's look at 40. Our factor pairs would be 1 and 40, 2 and 20, 4 and 10, 5 and 8. Our factor pairs for 72 would be 1 and 72, 2 and 36, 3 and 24, 4 and 18, 6 and 12, 7 and 8. So I'm going to now go and circle all of the common factors. 1 and 1, 2 and 2, 4 and 4, 8 and 8. And those are the only factors that they share. Then I look for the greatest of those factors, and I see the biggest common factor that they share is 8. I'm going to do the same thing, but doing it with the factor tree. Again, I like to start with 2s. So I would do 2 and 20. You could start with 8 and 5. It doesn't matter which factor pair you start with. I keep it easy and go right to that 2 prime if I'm able to. So the 2 is a prime, it stays. The 20 can be broken down into 2 and 10. The 10 can be broken down into 2 and 5. And those are all prime numbers. So it would look like 2 times 2 times 2 times 5. So we take all those prime numbers. Then I'm going to look at 72. Again, I like to go to my 2s. 2 and 36. We do 2 times 36, that equals 72. 2 is a prime, so it stays. 36, I can go down to 2 and 18. 2 is a prime, so that stays. 18 can go down to 2 and 9. 9 can be broken down into 3 and 3. Now we are down to all of our primes. 2, 2, 2, 3, and 3. So I'm going to write those out. 2, 2, 2 times 3 times 3. And I'm going to compare and see which primes we have. I see 3 2s here, and I see 3 2s here. So I'm going to say 2 times 2 is 4, times 2 more equals 8. And we get the same greatest common factor of 8. Let's do one more set to make sure we're understanding the difference between the two ways of finding greatest common factor. So let's do 12, 30, and 60. So if I start with 12, let's do our factor pairs. We have 1 and 12, 2 and 6, 3 and 4. Then let's do 30. We have 1 and 30, 2 and 15, 3 and 10, 5 and 6. And we have 60. We have 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. So that is all of our factor pairs for all given numbers, 12, 30, and 60. So my second step is finding the common factor that all 3 numbers share. So they all share a 1, they all share a 2, they all share a 3, they all share not a 4, not a 5, they all share a 6. They don't all have 10, they don't all have 12. And this one only goes up to 12, so we know that's where we're done looking. So now I need to look at my greatest number is 6. So the greatest common factor of those 3 are 6.
If there are any JV boys soccer players at school, your game has now officially been canceled. If any JV boys soccer players are at school right now, your game has officially been canceled. Thank you.
Okay, and now we are doing the factor tree and see if we get that same greatest common factor of 6. So let's look at our 3 numbers. We're going to start with 12. And that 12, like I said, I like to do my factor pair that has a 2 in it first. So 12 is 2 and 6. 2 is a prime number. 6 can be broken down to 2 and 3. And those are both prime numbers. So it's 2 times 2 times 3. For 30, I'm going to go with my 2 and times 15. 2 is that prime, it stays. 15 can go down to 3 and 5. 3 and 5 are both prime numbers. So we have 2 times 3 times 5. Then we have 60, 2 times 30. 30 can be 2 times 15, and 15 is that 3 times 5. So we have 2 times 2 times 3 times 5. So we need to compare what they all share, what prime factors they share. And I see in each of these, I see 1, 2, and 1, 3. So they all share a 2 times 3. And 2 times 3 equals 6. And we got the same greatest common factor going either way. It doesn't matter which way you use, you get the same greatest common factor. So you need to decide, does it make more sense for me if I do my factor pairs and I make sure that I find each pair of numbers? Sometimes we miss a pair of numbers. Or should I do the factor tree and make sure I come down to those prime numbers? Some of us have a hard time remembering that 6 is not a prime number. I can still divide it down. I need to simplify it more. So if you're going to do the factor tree, you have to make sure you break it down to those prime numbers that we were talking about last week. And if you do your factor pairs, you need to make sure that you list every single pair so you can see all of those common factors. The one thing to keep in mind at the bottom of this page, so I need to scroll it down. At the bottom, there is a note. Numbers are relatively prime. It sounds pretty cool if you say it in a British accent. I do not do accents well, so I'm not even going to try. But numbers are relatively prime if their common factor is 1. They are not prime numbers themselves, but are prime when compared to each other. 8 and 15 would be an example of this. So if we look at 8 and we look at 15, if we're doing factor pairs, we would have 1 and 8, 2 and 4. 15 would be 1 and 15, 3 and 5. We're going to circle our common factors, and we are only circling the 1. So that is the only common factor they have. When we're doing our factor tree, we have that 8 and 15. I would do 2 and 4, 2 and 2. So it would be 2 times 2 times 2. This would be 3 and 5. So it would be 3 times 5. We know that each number can be multiplied by 1. So if they don't share any other factor, we go straight down. If it's relatively prime, we say its greatest common factor is 1. The homework to go along with this is both page 10 and 11. So make sure you are doing both page 10 and 11. On page 10, it says show your work. So I want to see if you are doing factor pairs or if you're doing the factor tree, so I can see how you're doing, if you're getting the correct greatest common factor, and if you're not, where the mistake is happening. So remember, if you're doing factor pairs, show all of the pairs and then circle the common factors. If you're doing the factor tree, make sure you are breaking it all the way down to the prime numbers. And with that, you are going to get working at home, and I'm going to stop sharing.